All right, let's dive into one of the most useful tools in the entire data science playbook. It's called Logistic Regression. And really, it's all about helping computers make simple but critical yes or no decisions. You're going to see it's the secret sauce behind a ton of the smart tech we use every single day.
So think about this for a second. How does your email app, like Gmail or Outlook, just know what's junk? How does it make that call to shun an email into your spam folder before you even see it? Well, that's a perfect example of what we're talking about today. It's a classic yes or no problem. Is this spam or is it not?
And once you start looking for them, you see these kinds of questions everywhere. Will a customer actually click buy? Is this credit card charge legit or is it fraud? Will this patient respond to a new treatment? All of these incredibly complex situations at the end of the day boil down to a simple binary choice: a yes or a no, a 1 or a 0.
Now, to make these kinds of predictions, we absolutely need the right tool. And your first instinct might be to just try and draw a straight line through the data to find a trend. That's something called linear regression. But for our yes or no problem, it's just the wrong tool for the job.
Here's why. See, linear regression is great for predicting something continuous, like the price of a house, which could be any number. It gives you a straight line. But logistic regression, it's playing a totally different game. Its goal is to predict a category, or yes or no, by giving us a probability, something between 0 and 1. And that creates this beautiful, characteristic S-shaped curve.
So why is that straight line so bad for this? Well, imagine you have two distinct groups of data points, like spam and not spam. Trying to jam a straight line in there to separate them is, well, it's clumsy. It just doesn't fit right. It can't cleanly divide the two groups, and it ends up making a lot of mistakes, especially at the edges.
And that leads us to a really clear, simple conclusion. When it comes to classification, putting things into buckets, linear regression just isn't the right way to go.
And this is where logistic regression steps in. It's really the hero of our story today. It completely ditches that rigid straight line and instead trades it for a much more clever, flexible S-curve that's perfectly designed for exactly this kind of problem.
The secret ingredient that makes this all work is a really cool mathematical tool called the Sigmoid function. The best way to think of it is as a kind of squashing machine. It can take any number you throw at it, any number, positive or negative, huge or tiny, and it neatly squishes it down so the output is always a value between 0 and 1.
Its job is actually pretty simple and super elegant. First, you feed it any input value. Then it applies that S-curve transformation, that squashing logic. And what comes out the other end is always a clean, understandable probability.
And this transformation from just any number to a clear probability, that's the whole key. Instead of trying to force a definite yes or no, the S-curve gives us the likelihood of a yes. It's just a much smarter, more nuanced way to handle the problem.
Okay, so our model used that awesome sigmoid function, and now we have a probability. We have a number that represents a chance. But how do we get from that to a final concrete decision, a real choice?
Let's say our model queues on an email, and after all its work, it spits out this number, 0.82. This is the model's calculated probability that the email is spam. So what do we do with that? 0.82? Is that a yes, it's spam, or a no, it's fine? The computer needs a clear, simple rule to follow to make the final call.
And that rule is called the decision threshold. You can just think of it as a line in the sand. It's a cutoff point that we decide on ahead of time, and it's what turns that probability into a final answer. Most of the time, we just draw that line right down the middle, at 0.5.
The logic from here is incredibly straightforward. If the probability our model spits out is greater than that 0.5 threshold, we classify it as a 1, a yes. If it's less than 0.5, we classify it as a 0, a no. So, our email with a probability of 0.82, well, that's way over 0.5, so that's a definite yes. Straight to the spam folder. It's really that simple.
Okay, let's bring this all back to the real world. Because this isn't just some abstract idea. This simple, elegant logic is the engine behind a huge amount of the technology that we all rely on every single day.
Just look at these examples. The spam filters we've been talking about, for sure, but also medical systems that help doctors predict if a tumor is benign or malignant, or banks deciding in a split second if a transaction is genuine or fraudulent, even marketing companies predicting if you're going to purchase a product. All of them are powered by this amazing ability to turn messy data into a simple yes or no.
So the next time an ad seems to read your mind, or a spam text gets blocked before it even bothers you, you'll know there's this really cool, elegant logic working behind the scenes. And it kind of makes you wonder, right? With all the data that's out there in the world, what's the next big yes or no question that you'd want to be able to predict?